Hello, everyone. My name is Raylan Bovair, and I have been hired to investigate the string of fish deaths that have been occurring at the local beach. An event like this can be an indicator that there is a toxin contamination present, since fish are highly susceptible to chemicals and toxins within the water. Three main questions and concerns that will give us a little bit of insight into this problem are determining exactly what the toxin is, where it is coming from, how it is entering the water, and if there is a negative effect on the health of the fish and the people. I suspect that our chemical culprit is organochlorine, which is a toxin that is commonly used in insecticides. It is sprayed on commercial produce, gardens, and livestock, to name a few, to protect them from the infiltration of insects. It's an organic compound that contains a covalently bonded chlorine atom to a carbon structure. This makes it have high lipid solubility, meaning that it is capable of dissolving in fats. This makes it easy for it to pass through the cell membrane and its lipid bilayer. They have low water solubility, and it is also highly toxic and can cause some serious health issues. Now, how does this chemical enter our waterways from the areas where it is typically used? It begins with the application onto vegetables, fruits, trees, livestock, and so forth. The excess will naturally seep into the surrounding soil, where it can stay for some time. However, once there is a melt of snow, a storm, or irrigation that causes a surplus of water that cannot be absorbed by the soil, water flows into nearby rivers, streams, lakes, and oceans, taking soil and chemical particles with it. This is known as runoff. Once the chemical enters waterways, it can poison organisms, as we've seen with the fish. Organochlorine can cause some serious issues. One of the reasons for this is its ability to bioaccumulate. This means that it continues to accumulate within the organism over time at a rate that exceeds its ability to excrete or metabolize the toxin, meaning that it becomes more and more concentrated as time goes on and becoming more and more dangerous to the organism. Due to organochlorine's high lipid solubility, it tends to become concentrated within the fat cells or tissues with high lipid content. Some examples might be the adipose, liver, and brain tissue. They will also accumulate in the fish's gills, causing gill disease that will severely hinder their ability to extract oxygen from the water. This bioaccumulation of organochlorine can inhibit cells' ability to undergo glycolysis. This process is absolutely necessary, as it breaks down the carbohydrates that are essential to supply energy to the cell. Without the necessary energy to go about their normal functions, cells can experience necrosis, which is the death of cells within the tissue. This cannot be reversed and is permanent. Toxins such as organochlorine that can bioaccumulate can also cause biomagnification of the chemical as it travels up the food chain. Biomagnification is the higher concentration of toxins in species that are farther up on the food chain. This occurs because the organochlorine has accumulated within their food and is absorbed by their own tissue upon consumption. Organochlorine poses a huge risk to the health of both aquatic species and humans due to its high toxicity and ability to bioaccumulate and biomagnify. As its toxicity increases over time, this will lead to life-threatening issues such as numerous liver, pancreas, and neurological diseases, as well as cancer. As we're currently witnessing now, it will most certainly cause a decrease in the populations of aquatic animals in the area. It is highly suggested that people avoid contact with the water, as well as consumption of aquatic species surrounding the area. It is also suggested that further research is done on the effects of the wildlife in the area. Thank you so much for listening.